Hi everyone, let's solve this problem. Combination sum. Given an array of distinct integers, candidates and a target integer target, return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combinations in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of them chosen numbers is different. And this is not really useful for us. This is just to handle the time. So let's say, for example, this is the example we have. Then what they are saying is like I can choose the same candidate any number of times. And when they are saying two combinations are unique, what they are saying is like 2 2 3 3 2 2 will be same, but either this or this, like if we change one of the frequencies of the numbers in the given answer, then it would be considered as a unique combination. So yeah, let's try to understand this solution by using a backtracking tree. Before that, if you haven't watched subsets solution, I will link the video link in the description. Please go through it before this, that will be helpful. So here in this case, let's say I have the array as 2 3 6 7. Our target is 7. Now let's say I start with the empty array. Let's say I pick up 2, then I will go into this. I'll again pick 2, I'll again pick 2, I'll again pick 2, because I can pick a particular number any number of times. But in this case, if you add, it is 8. 8 is greater than 7. That means this particular, any further exploration of this path will not help us. So we will return from here. And this is done. Now we will take a next element, 2 2 3. 3 is our next element in our array. So I will take this. This sum is equal to 7. So we will stop here. We don't have to go forward in this case. And also one of the reasons because we don't have to explore further is that there will not be an element which is 0. So let's say, for example, if I give 2 2 2 3 and 2 2 2 3 0, they will still have the same sum, right? So there are no zeros in the given candidates array. So we don't really have to explore further. So once this is done, what will I have to do? I will again backtrack and I will go back. I will backtrack and be here. In this case, now I will take 2 2 3. So again it will have 2. I will take 3. I will take 6. So in this case, again 4 plus 6 is 10. Like we will not be able to go forward here. Same thing happens here. So again we will backtrack from here. We do not have any answer, so we will backtrack from here. This particular entire subtree is done. Then we will move back here. So again we will select 3 from here instead of 2, because we have selected 2 in the other part of the tree. We will select 2 comma 3 here. Again it will have, I can repeat 3 or I will select the next element, right? Again let me, so since this is there, I'll just erase this part so that I can draw the other tree. So let's say, for example, I can still take 3 or I can move forward with, either of the cases will not help because they are more than that. Then again I'll go here. This is already more than our expected target, so we will try, because this entire subtree is done. I'll move back here. Now since this is also done, we will again move back here, and here we will take 3, right? Because 2 is not taken, we will take 3, and again we'll do the same operations here. So now let's try to write the code for this. So we will need candidates, target, index, result to store the result, current subset. These are some things which we need. Now let result equal to this, let subset equal to this. Like subset is the current subset, which we don't really have to call it a subset because we are not only picking unique elements, we are repeating it. Let's say current value in this current. Okay, now we will call backtrack of candidates, target, index, and result and current, and then we will return the result. Now if the target, okay, let me first write the recursive cases. I will first push my current dot push of candidate dates of index, then we will have, okay, candidates will be passed, target, since we are taking our one of the elements, next target will be target minus candidates of index. This is the value, because let's say for example I have 7 and I am taking 2 minus 7 is 5, so we will be passing 5 as the target sum from here. And then index is the same index, because it is possible that we can repeat the elements like 2 in the case which we saw, so we can still allow it to take the further same value, and result and current. And now we will remove our element from the array and we will again backtrack, but we know that we did not choose the element, so target will remain target and index will be index plus 1, because we are not taking the current element, we have to take the next element, and result and current. And if let's say target is equals to 0, in this case what will happen is we just have to push our current answer into, so this is the use case. Let's say for example we have reached till the end and we found that this particular combination is giving us the target as 0, because we are from the target value we keep reducing and we should reach target as 0 and then we'll push it, and once we get it we don't really have to go for further, so we will just return it. And then if target is less than 0, because all the numbers will be like positive, so we don't really have to worry about the negative cases. So target is less than 0, or the index is greater than or equal to candidates dot length. In this case also we don't really have to do anything, because we have actually reached the end of the given candidates list, or basically target is not possible. And yeah, I think this should be good enough. Let me comment this out. Okay, let's try to run it up. Index is not defined. Okay, initially we have to pass 0, so okay, it's a typo, sorry. Okay, let's submit it. Great. So now let's also understand the time and space complexity of this algorithm. So generally if there are n elements and if we are exploring all the subsets, it would be 2 power n, but it is different in this case because let's say for example n elements are let me take a example to make you understand. Let's say 2, 3, 5, and let's say my target is 15, or let's say I will take a 30. So if you consider, I can take 2 comma 2 comma 2 so on 15 times. I can just take, for me to get 30, I can take 3 into 3, 3, 3, 3, 10 times. And to just get 30, I will take it 6 times. Right? I'm just giving you one example. Let's say, for example, among all the numbers, we just have to observe one thing. N is 3. But the number of recursion calls which we need to go through to get this particular answer 2 to 2 like 15 times, because we have to return all the possible combinations, right? So the maximum will be the smallest element, which is nothing but 2 in this case. Target is, let's say, 30. So target by smallest element, right? Because if you compare n versus this, let me call it as t by s. So n is less than target by smallest element, right? Because of which the time complexity of this solution will be 2 power t by s, and space complexity of the solution would be t by s for recursion